Yula, you're in. Please unmute and talk.
Hello, sir. Can you hear me now, sir?
Yeah.
Yes, sir. Dear participants and fellow mates, a very warm welcome to one and all present here. I hope you all enjoyed yesterday's session. Thank you for your eagerness and patience throughout this FTP. And I have an announcement for you. The link for the attendance has been posted in the WhatsApp group as well as the WebEx chat box every day. I request for the participants who have registered and got approval from AICTE to fill out the attendance form without fail. And for the participants who haven't got any approval from AICTE, no need to worry, you are welcome to enrich your skills. And the certificates will be issued only to the participants who have registered, got approved and has 80% of attendance. And I also request participants to mute their mic as well as the video throughout the session. I repeat, I request participants to mute their mic as well as the video throughout the session. And the presenter has some technical issues. I request you all to be patient for some more minutes. Thank you so much.
Yeah. Good morning, Senthil sir.
Yeah, good morning, sir. Sorry, there's been a bit of delay.
No issue. The speaker has joined. You can start.
Okay, sir. Okay, sir. Now it's time for our next session. And the first session topic is about building a data model from the scratch. Now I'd like to introduce our speaker of this session. Dr. T. Senthil Kumar is currently working as assistant professor in computer science and engineering department at Amrita School of Engineering, Amrita Viswa Vidyapeetham, Coimbatore. He has received appreciation in Indian Express for agent-based programming for banking domain. He has publications in 9 international conference, 12 national conference, 14 international journal and 2 edited book chapter. He has publications in 19 Scopus Index publications too. He has published a book on C++, developing the competency areas of programming JIS.NET, CV, Spark, deep learning, embedded automations. He is also a part of funded project from IBM, DST and Ministry of Tribal Affairs. It is such a great privilege for all of us for you to be with us this morning. Thank you so much, sir, for your presence. Now, I call upon Dr. D. Senthil Kumar to start the upcoming session. Over to you, sir.
Yeah, before Senthil, 1 second. I'm very sorry. Bulash, he's working as an associate professor, not an assistant professor. Okay. So he is an associate professor from Amrita Vidyapeetham, and the rest he is well known for his profile. And over to you, Senthil.
Yeah, so thank you, Dr. Chandramouli sir, and thank you to the member who has introduced me. So it's nice to give a talk or more on the topic which is more related to me and the area that I've been working for so long. And I would like to share that I have 3 topics that I have in the forthcoming session. One would be building a data model from scratch, and second would be how to develop a CNN model, and third concept would be like how to write code and how to program with RNN, that is a recurrent neural network, right? So these are the 3 topics that I have in session. So limited to the knowledge that I have been learning and keeping it forward. I hope the session will be useful to all the participants. Understanding the network bandwidths that we generally have as problem. So I'm just putting off the video and I will start with the presentation sharing. You are getting stuck anywhere, please let me know. so that it is easy for both of us to understand that we are listening and we are learning from the session part. Uh, okay, now I put off the video. Now I'm sharing the presentation, which I'd like to take for the audience. Okay. Um, Now I'm trying to share my presentation screen. Yeah. Hope you are able to see my slide. Hello.
Yes, sir, it's visible, sir.
Yeah. Okay. Thank you. Okay. See, for all of you, like going around the data and trying to look at what data is, the basic question is like, why are we very much worried about looking at data, and what do we want to reason from data? See, to all the people, I usually put this one statement, right? You need to look at your problem that you want to solve. The problem that you're trying to solve can be a problem that is already solved, or it can be a problem that is already existing, right? So, if it is a solved problem, whatever effort that you're taking might not be immediately appreciated. So, you need to go around the problem and say to the people that whatever you're doing is unique, and the problem needs a lot of more attraction. So you're trying to build some models or algorithms to solve the problem, right? So for this, usually I put one example. If you go back to December 2019, and if you had started looking at a COVID data set, right, and you had written your first algorithm, which can be on k-means clustering or k nearest neighbor, and you are trying to use that algorithm to solve or predict how the COVID is spreading in India, right? There, your publication would have come very much better. So there it is an unsolved problem, right? Now, if you talk about COVID now in 2020, right? Now in October, if you say that I'm looking at a deep learning architecture also, people will say that there are more than 13,000 articles that has already come in COVID. And what is that you're trying to do unique, right? So yeah, problem always has attraction in the way in which you approach. So the earlier you strike the problem, any small model that you develop or any small algorithm that you develop for solving the problem will have a lot of attraction, right? This I'm saying to all the participants because people generally look at algorithms and then go back to data. But what I generally say to people is like, look at the data first, see how much the data has been explored by the community, and then go to your algorithm. Right? So the agenda for session would take you through to understand like the concepts that we are trying to explain. Right, one is basically about why everybody is talking about deep learning when there is something called as machine learning, and how do you build a data model, right? So usually when you have some data that is in front of you, the data is understood to be a set of features, right? So features means every single column that you take around your data is called as a feature, right? The features are very interesting because they give you a lot of insight about the data. For example, if you ask like what can be the smallest data that can be there, right? One person in the beginning of the session has been giving a small information about today's talk and has been saying, okay, I'm going to present a topic, right? Now, if there are sensors in that particular room, that sensors will say that, okay, what is the temperature, what is the date, okay, and how much amount of humidity is there. Each one of it here is called as a feature. So date is a feature, humidity is a feature is going to be the future. Based on the humidity and moisture, you can always say that I'm trying to control the amount of AC temperature that I'll have in the room, right? So the amount of AC temperature that you're going to have is what is going to be predicted, right? So given a data, you are interested in predicting how much is going to be the AC temperature, right? For this, if you ask a question, everybody will say, see, there is something called as humidity, there is something called as temperature. I will, hello, can you hear me? Hello.
Yeah, we can hear you, sir. And
Okay.
it is better if you put it in the full screen mode. That's what participants are requesting.
I'm trying to do that.
Huh.
Is it coming in the full screen mode now?
No.
Hello.
It's coming, but please
Sir,
speak.
it's full screen.
Okay, and you can click on the hide button, Senthil. That CUT and WebEx is sharing your screen. That message is there. Nah, click on the hide button. Yeah.
Yes, sir.
Yeah.
Now is it okay?
Yeah. Thank you.
Okay. Yeah, thank you, sir. Thank you. See, let's take you going back to the same example. There is a room temperature and there is a humidity that you talk about. People will say that, okay, given the temperature and the humidity, you can look at a rule-based algorithm, and a rule-based algorithm can say what is the temperature that you want to give for your air conditioner that you set in the room. So problems like this can be solved just with rule-based algorithms. So there, I'm keeping it to the audience. Popularly known algorithm, even now very popular, and mostly why whenever you're looking at prediction, you can go for decision. Now the other side of the story is very different. Let's take last Monday, your climate was very good, and this Monday is also climate is very good, right? And next Monday, your expectation is the climate is seems to be the same good. Then there is no difficulty in uncertainty with respect to the data. But assume a case last Monday was very cold, and this Monday is very hot. Next Monday is again hot, right? You're not able to predict what can be the climate of the particular day. There, the uncertainty of the data becomes very hard to predict. So the next keyword that I'm presenting to the people is look at the uncertainty of the data. If the uncertainty is very high, then you cannot go for conventional techniques. You have to go for techniques which can handle such uncertainty. There, the popular technique is machine learning, and you can put an added keyword saying how much uncertainty exists. If the uncertainty is low, you can go for machine learning. If the uncertainty is going to be very high, there you can go for something called as deep learning. Right? Okay. So the first keyword would be is like look at your data, see whether there is an uncertainty in the data. If the uncertainty is low, you can go for machine learning. If the uncertainty is very high, there you can go for deep learning. Now let's take you ask you a question. Okay, what about the case of a COVID data that somebody wants to analyze? The COVID data has got uncertainty, right? But it is time varying. So there you need not go for deep learning. There you can solve it with regression models itself. Right now, I'm putting the next keyword as difference for you, whether the data is going to be discrete or whether the data is going to be continuous and how much it is varying. So based on the discrete or continuous nature of the data, you can go for models which are based on regression, or you can go for models which are based on deep learning. Okay. Now, this slide is a small comparison slide which can get you a glimpse about where you should go for machine learning, where you should go for deep learning. See, common thing is given some data, if there's a class label in the data and the class label is already existing, there you can go for algorithms which are supervised models because there is already a data, there's a class label for the data. I can access the test data and I can predict. There I can go for supervised algorithm. Now, there is no class label at all. So what should I go for? I should go for. You go back to November 2019. You got the first data for COVID. There is no class label for the data at all. There's no learning for the data at all. There you should go for unsupervised. Now, if you go for your COVID data now, let's take in October 2020, there's already a classified data. There you can go for supervised algorithms. So both machine learning and deep learning gives supervised and also unsupervised algorithms. Now, the last difference people should be willing to accept is the accuracy factor, right? Now, accuracy is more connected to what you want to predict from the given data. I'm investing 1,000 rupees. I want 1,000 rupees back from the share. So my accuracy is I'm expecting 100% I want back, right? But I'm investing 1,000 rupees, but I'm getting only 500 rupees as benefit. That means I have achieved only 50% accuracy. So the accuracy is more connected to the data part, right? Now let's take for example, a doctor understands that the patient is having a temperature of 95. The doctor believes that given a medicine of this dosage, of this much of ml, the temperature comes down to 92. How much accurate does it happen? That's the biggest question, right? Okay. So accuracy is one other factor that will make you to understand that you want to go for machine learning or deep learning. So accuracy is high when you go for deep learning. Around this, people talk about the next keyword, something called as transfer learning always, right? Transfer learning is important when your data is very small, right? You cannot create a big data at all. There, what is the solution is go for transfer learning. So a typical example would be is like, let's take you want to detect fire, okay? You are interested in developing a model to detect fire. How much amount of video data can you create for fire? It is not easy. I think people will agree. But if I ask you a question, can you create a traffic video? You would say, yes, it's possible. I can take a camera, go to the road, right? There are many vehicles going. I can record the data. I can stand for hours together. My data becomes a big data. But can I ask you a question? Can you create a fire and make it as a bigger fire and record a bigger fire? It is not possible. So the data is limited. There in such cases, what you do is you go for something called as transfer learning. So your model samples need to be very important in judging your algorithm. If you feel that your data model samples are very less in nature, please do not go for deep learning. Please go for transfer learning. Okay, so transfer learning is also picking up like anything in the market. Now, the keywords around on the other side, which I'm putting into the slide, is any meaningful information about a data is called as a feature, right? Now, let's take, I ask each one of you, what can be your features? You would say, I study in this university, so I have a roll number, I have a name, I have an address, right? I have a father's name, right? Now, let's take, I ask you, what is your societal status? Just take it for information. If I ask you, what is your societal status? You say, my societal status is high and my societal status is low. So that high and low corresponds to something more. If I ask you, why do you say high? Okay, your societal status. You might say, my father works in a so much of designation, right? My mother is also working, so naturally my societal status is high. Somebody would say, no, I do farming, so my parents are also very much involved in farming, so we feel that we have a higher societal status. So a feature, a value for a feature is dependent on some other features which you can call as metadata. Okay, so whenever you build a data model, make sure that you create as much of features that you want so that your model becomes very meaningful. Fine. Okay, so next is classification and prediction are too much sometimes complementing each other. If you have a data that's a class label to the data, it's called as class. Okay, and the process is called as classification. Now I'm giving a data, I don't know what the class is, so I'm finding a class for it. There it's called as prediction. Usually what I say to my team of students, my scholars, everybody would be like, given a data, there's no class label, you're doing classification, right? That means there is no ground truth for the data at all. So what algorithm are you applying? You're going for an approach of unsupervised models. I have a data, the data is having a class label. Now I'm giving a data, I want to know what is a class label for it. There what I'm doing is prediction, right? So there what I'm using is supervised algorithms. So classification hyphen unsupervised algorithm. Prediction hyphen supervised algorithm. Okay. Now the next keyword that I'm putting up here is more on the neural network, which people should agree, right? Most of the deep learning architectures are inspired by neural networks. There is no what is it alternate for it, right? Because neural networks has been the very inspiring idea saying that if systems can really model what humans think, there you what you are saying is you're building something called as a neural network, right? We will come back to this to discuss more on the ideas, right? Now, when you are actually trying to do a model generation process, and let's take you're going with a neural network idea. So what does neural network says? I give you something called as neurons, right? So given some neurons, what I'm interested to say to you is like, okay, I give you something called as activation function. So the activation function can fire the neurons. So the neurons can work together with the weights, right? Finally, it can associate it to a respective class, right? So the keywords are neurons, activation function, right, and output. So given some neurons with an activation function and the given set of inputs, you are trying to have a bias and you are trying to associate it to an output class, right? This is what you would have learned as saying summation of x is your given data. So summation of xi, because there are many neurons, multiplied by each of its weights, right? So summation of xi into wi, right? Right? Okay. So plus B, that's your bias, will give you a equivalent class that which to which you can associate. This is the principle in neural network. Now come to the other side on deep learning. What does deep learning says is deep learning also says the same. Deep learning says I give you neurons, right? I give you weights, I give you activation function. But deep learning differs in one other way. What is the way it differs is it says that, see, all weights will not remain the same. This is the first difference. Please understand. In neural networks, it's not like that. All weights will remain the same, right, at every iteration. But deep learning is not like that. At every iteration, all weights will not remain the same. So the weights will be adaptively changing. So if there are n weights, okay, n weights that are used in the case of neural network, if you come to deep learning at every iteration, not n weights need to be used. There can be less number of weights that can be used. So which will be decided based on the model architecture. This is first difference. Second difference is when you're coming to the case of neural network, what you will have is something called as activation functions, which are linear activation functions, right? But when you come to the case of deep learning, it's not like that. Mostly what you will have is something called as non-linear activation functions. Okay. So deep learning gives you non-linear activation functions, right? Okay. Now let's come to the third part. When you are trying to have a neural network, right? And you say that I am building a neural network with neurons and layers, you will say there are something called as layers. Layers are called as hidden layers, right? And it's a principal rule that if every hidden layer, you will have the same number of neurons. But when you come to the case of deep learning, it's not like that. At every hidden layer, you can have your number of neurons modified. That means at first hidden layer, I can have 6 neurons. At second hidden layer, I can have 4 neurons. At the third hidden layer, I can have 6 neurons. So the number of neurons at every hidden layer can be modified when it comes to the case of deep learning, right? Now, the last difference is like this. Yeah, when you are training a neural network, when it will stop, the neural network will say it will stop when the number of iterations have completed. That means the number of epochs have been completed. I give you 10 epochs, okay, the neural network will run for 10 times and finally it will converge to the respective class and it will give you a error value that matches. But deep learning is not like that. Okay, you can give you a stopping criteria based on two factors. One factor can be your number of epoch. You can say, I just run your deep learning model for 1,000 times. It will run, it will complete. The other way of asking the deep learning model to help you is saying that, okay, run for it's any number of times. Please understand, run for any number of time, but make sure that your training error or your testing error is only this value. So that is the last difference between your deep learning and neural network. Okay, because of this reason, people say that deep learning model cannot be running in normal computers. You need a higher end processor, okay, and you need a higher end system. Only then you can run for deep learning, right? This is fundamental difference between your neural network architecture and deep learning architecture. Why we are talking about this again and again is we need to know how much deep learning models actually are relevant to neural network, right? Now, this slide is actually to give you a quick glimpse about, okay, what are the fundamentals that you need to know, right? First one would be forward propagation. Second one would be backward propagation. So now if you look at your case of deep learning architecture, it will say that at every iteration, right, given inputs are xi, right, with its weights, right, it will actually correspond to an equivalent output, right? Now, backward propagation is something like it goes backward because the iteration is not completed. At every iteration in the backward, it readjusts the weights. So the weights that has participated in the learning alone will be taken, and will go forward, and again it will calculate the class value, which will say the given the data, it is falling into a respective class. So that is about backward propagation, right? And third one is something called as gradient descent, and fourth one is called as perceptrons. We'll come back to gradient descent and perceptrons. Now let's look at this here. If you look at these inputs that we give, x1, x2, x3, right? And let's take, we say x1 is 0, x2 is 1, and x3 is 1, and we are setting a threshold as 0, right? So it means that if you sum all these three, x1 plus x2 plus x3, naturally here what will happen, it is 0 plus 1 plus 1. It is going to be greater than 0, right? So there our understanding is output will be 1, right? Otherwise what will it stand is, it will stand it as 0, because we are setting the threshold as 0 here, right? So here what perceptron will say is, perceptron will say given inputs as 0, 1, 1 for x1, x2, x3, the output equivalent is 1, because it has exceeded the threshold, which is 0, right? Now let's start putting what weights will do. Now weights are more important to the given data that you provide. So the given data is x1, x2, x3, right? Now we start putting the weights. Let's give some weight values. W1 can be 2, W2 can be 3, and W3 can be 4, right? X1, X2, X3, we already know it is 0, 1, and 1, right? Now when you want to compute the output, what we'll do is we'll multiply the input with the weights. So what is the input? 0 into 2, right? 1 into 3, 1 into 4, right? So what we will check is, after you multiply, we will say whether it is exceeding the thresholds, right? Now, if it is exceeding the threshold, what we will understand is the model can learn better, right? If it doesn't go properly, what we do is we start going back and we start modifying the weights, right? Now, next keyword here is, which I've been saying, is called as bias. So each perceptron here will have a bias, which will say how much flexible the perceptron can learn, right? You can actually come to assume it as a linear function. A formula for a linear function is y is equal to ax plus b, right? So what will happen is, a linear function, what it will do, it will try to move the line up and down to fit the prediction so that the data is predicted properly, right? Now if you ask a question without bias also, can we do? Without bias also it will give you, but what happens is you might not get a proper fitting of the data. So the importance of bias would be is like importance of the bias would be is to fit the given data, right? So now what will happen is, your data will actually get modeled like this. It will say w1 into sorry w1 into x1 plus w2 into x3 plus w3 into x3 plus 1 into b. B is nothing but your bias. Okay, right? Now the next keyword that is very important is called as activation function. So as I told you, we have non-linear activation functions more in the case of deep learning. So what is an activation function will do is, we have got the sum earlier, right? W1 into x1 plus W2 into x2 plus W3 into x3 plus 1 into b, right? It will actually take it as an argument and it will say what is the output from the given neuron, right? So the output will be either falling as a class value. Here the class can be binary or multi-class. Now let's take it as a binary class. If it's to be a binary class, what happens? The value will be either 1 or the value will be either as 0, right? Okay. So now let's come to your activation function. So an activation function can be expressed like this: f of summation of I equal to 0 to n wi into xi. W is nothing but your weight, and x is nothing but your input data that you have, right? So the use of an activation function is to make a nonlinear transformation that will allow you to fit a nonlinear hypothesis, right? So a nonlinear hypothesis, why are we saying? We are saying because we have not been able to classify the data. So a hypothesis is generally nonlinear, right? So it allows us to fit a nonlinear hypothesis so that we can estimate the equivalent class it follows, right? Okay. Now, in this case, what goes to the notations back is, it says that x1 to xn becomes the inputs to the neuron, right? X1 to xn can be your understanding. For example, if there are n features, okay, every row of data that you take can actually be taken as one data, right? So what is x1 is your choice from your given data, right? Next is x0. Bias will be the x0 value. It will be initially set as a constant value, right? Okay. Next one will be the weights. Weights are dependent on the data that you have taken, right? And please always understand the bias also will have a weight, right? So it's not that inputs alone will have the weight. The bias also will have the weight. Initially, the weight is taken as 1. You can see here. It is 1 into B, right? Okay. Now, going forward, this is next information to the people. What we are trying to find is, given a data, we want to find a hypothesis, right? So hypothesis is something similar to a line equation that you fit always, right? Now,
Excuse
just
me,
need a yeah.
I have a doubt, sir. In
Yes.
this activation function in the formula, we have wi into xi.
Yeah.
So here wi is the weight, and what
X is the input data.
xi is the input data.
Correct.
Now, if you say xi is the input data, or you can say xi is the vector.
X is the
xi is the input data, or xi is the vector data.
xi xi is the input data, or xi is the vector data you're asking, correct?
Yes.
Yeah, okay. Going back to neural network, you would always say that it is a vector data. Xi is a vector data.
Okay, sir. If xi is the vector, then when we are talking about wi, what do you mean by weight in the practical sense?
Okay, what is weight? Is weight will influence the data. I will come back to that. Okay, I'll keep this question for you. I'll show you an example and say you how the weights changes.
Okay, I think, sir, my question is clear. My question is, if xi is the input data, then what is wi practically? I want to know.
I understand. I understand. I understand. Okay,
Oh,
I'll say you like this. See,
okay.
if there are 10 columns of the data, okay, if there are totally 10 columns in the data, the sum of the weights should be 1. That's a rule. Okay. So what will be the initial value for the weights? 1 by 10.
Uh, 1/10.
Okay. 1 by 10. So initially what it will do is it will assume a uniform weight to all the individual columns. Fine. Okay.
Okay.
With
Okay.
that, it will try to model the data. It
Okay.
will try to classify. Okay. Now here
Okay.
what we are doing is we are trying to have a uniform weight setting measure.
Okay.
Now, if you come out of there and you go down to the deep learning, what the deep learning will say is how much amount of maximal information that you can learn from the data is dependent on the weights.
Okay.
That means at every epoch, what the deep learning will do is it will converge and give you error value.
Okay.
Right? So if the
Yes.
if the error value is going to be reduced, what it understands is whatever weights it has set is correct.
Okay.
Okay. Let's take the error value is keeping on increasing.
Okay.
What it can do is it can go back and see which weights have contributed to the increase of error.
Okay.
Okay. That weights alone will be adaptively changing.
Okay. So that means W is not any data. It is a parameter only which influences the error, whether it is decreased or whether it will be increased.
Yes, W is a weight which will carry a numerical value, right? It is not data.
It is not data. Sir,
It is not
my
data.
last question
Hmm.
on how can we define the value of W
There are different ways
initially?
of doing it. There are ways of doing. One is go for a uniform weight measure, given the condition saying that the sum of the weights is 1. Okay. Then at
Okay.
every iteration, you can go back and check how much the error value is changing. There you can use some algorithms that you know, maybe it can be a bio-inspired algorithm also, right? Based on that, you can go and readjust the weights.
So that means initially when the neural network is trained, on a given set of data, and when the weights are given initially to that particular neural network, so there must be certain rule and regulation based on which every data is assigned with some weight parameter.
That's what I'm saying. Weights are set uniform.
Okay.
Weights are set uniform. It is dependent on the number of columns,
Okay.
right?
Okay.
If your data is okay, I'll put you a real example. If there are, yeah, if there are 10 columns and there are 7 records, okay. If there are 10 columns and there are 7 records, that means 10 features and 7 records.
Okay.
Okay,
Okay.
it is not uniform. It is not uniform, no. So what it does is like it gets converted into 10 cross 10 by doing a padding. Hello.
Okay. Yes, sir.
Yeah. So it gets converted into a 10 cross 10 by doing a padding. That means filling with zeros, right?
Okay.
Now what you're doing is you are giving every single column vector as a neuron, right? So
Yes.
every single column vector as a neuron means there are 10 columns.
Yes.
Yeah. So it will give a uniform weight. It will take a uniform weight as 0.1.
Okay.
Okay. That's the initial weight it will based on the learning mechanism that it tries to do. There it will go and readjust the weights. That is where we have other parameters like learning rate, type of optimizer, all that will go and influence the way the weights will change.
Okay. Okay. Yes, sir. I got the point.
Initially, the model starts with uniform weight.
Okay. Okay, sir.
Is it clear?
Yes, sir. Yes, sir. Thank you. Thank you, sir.
And I request the participants to keep your questions wait till the end of the session so that the flow of the presentation may not be disturbed. I hope you understand. Thank you.
Now, this slide should take you through the next understanding that we have been keeping on repeating. Left side, what you see is data, which is being given in the neurons. We have an input layer, we have a hidden layer, and we have output layer, right? Now, the connections with the weights, right, are shown in blue color, and the connection with the bias are shown in the brown color, as you can see here, right? So when the model starts running, what happens is every input data given to the layers, right, will actually have its weights and the bias that will influence, and it will fall into a corresponding class in the output. Now come to the right side, what we want to show is more about the hidden layers. See, when you come to deep learning, the more of thought process comes about when it goes to the hidden layers. Like you ask a common question, like you met a friend 10 years back, you walk on the road, you see the same friend, your mind comes back and says that this is your friend whom you met 10 years back. So where is your learning? The learning is stacked in some form of layers, and the number of layers are hidden. So the more the number of hidden layers, the more the better amount of learning. So right side, what you see is a model that we talk in terms of deep learning. So input features are being given, and what we have at every stack is a hidden layer. Now at every hidden layer, you can have the same number of neurons or you can have different number of neurons. And at the output, what we want to do is a prediction, which you can see on the right side, right? That is available will actually carry the data and the smallest information about the data, which will help us to say the corresponding class it falls into, right? Now, see, in reality, we talk about single hidden layer when you go to the case of left side, that is in neural networks. But when you come to the case of deep learning, it's not like that. We can have more number of hidden layers. Each hidden layer will have its own set of neurons. Now, left side, what you see is a full batch gradient descent, right? And right, what you see more is about a stochastic gradient descent. Okay, why do we talk about gradient descent, full batch, stochastic gradient descent? Is there is an interesting problem, right? People say that I'm using models, my models is able to predict, but more commonly they will complain saying that there is more of overfitting in the data, right? So when you want to reduce the amount of overfitting, what we talk about is we say you go for a proper way of gradient measure that you want to apply. So there are different techniques for gradient descent which you can follow. So this will help you to solve the vanishing gradient problem. It's a very interesting problem in deep learning. We will say, people generally say, I'm using RNN, CNN. Somebody will say, no, I'm using GAN. The answer would be is like, we want to reduce overfitting. So why you are looking at overfitting as a problem? We want to reduce the vanishing gradients, right? So please take this keyword also. When you want to compare deep learning architectures, just see whether it can handle overfitting, and you can put a hyphen and make a note somewhere, vanishing gradient problem. Now, the next thing is, okay, I have some data, I want to create a model. So the first question somebody would ask you is like, okay, what are the parameters you're interested in making? So the parameters, you would say, I'm using a particular architecture. So there is something called as weights, there is something called as bias. Okay, all that can be called as model parameters. But when you come to deep learning, especially in deep learning, people talk about something called as hyperparameters. So what is the difference is, parameters means fixed. Hyperparameters will means it will modify. That means it's keep on changing. That's a common difference, right? So model parameters are static, hyperparameters are varying. Just make a note like that. So what is an example of a hyperparameter? You can say learning rate. Okay, if you say learning rate is 0.5, it means that it will go till 0.5, for example, right? If you say epochs 50, that means it is only 50. It will increase 50, right? It's a fixed one. So certain things are called as parameters, certain things are called as hyperparameters, right? And next is hyperparameters will be helping us to more to understand about the model parameters, right? If you say I want to stop at epoch 15, the question would be like, how can you say it can stop at 50? So people will say this hyperparameter says with the value of this, the epoch can be 50 alone. So hyperparameters are required for estimating the model parameters. That's a direct thing, right? Okay. Then next is parameters as such will not be generally set manually, right? Hyperparameters can be set manually. And at every iteration, what you will be able to see is the parameters will help you to help in the training process, right? And hyperparameters will say how much your training is efficient. Okay. For an example, from what we have discussed now, a gradient descent will say that learning rate will decide how much accuracy is achieved in the optimization part. So a learning rate is an example of hyperparameter. Okay. So this is the information I want to take up for your part. So please, when you go to deep learning, ask questions for yourself. What are your parameters? What are your hyperparameters? Okay. Now, this taking to the next case, people will say how much your model is efficient. Okay, right? So people say, see, my architecture works for 1,000 records, but when I move to 2,000 records, it is not working. So what is the 2000? It is example is like, see, I got last 10 days data. It is 1,000 records. Now another 10 days have gone. It's 2,000 records. So what I worked for 10 days is not working for 20 days, right? So there we come to this problem of something called as underfitting and overfitting, right? Okay. So if your training data is not efficient, that means you're not considered most of the challenges in the given training data. So what happens is it leads to an underfitting problem, right? Okay. Overfitting is slightly different, right? What is overfitting would be is like your amount of error, right, that you get on the testing or validation data set will be more greater than what you get in your training data set, right? And you find that, okay, you start increasing the data, there's a lot of inaccurate predictions. So that leads to something called as overfitting. Okay, so please, you can compare your models based on these two keywords, whether your model is able to solve underfitting and overfitting. Okay, when you say underfitting, then naturally the next keyword, no, what I told you, vanishing gradient problem also will come to your side and say that, okay, does your model solve the vanishing gradient problem also, right? Now, I want to solve overfitting because I have some data. There's a lot of overfitting in the data. What are the solutions? One is you go for something called as cross validation. Okay. Now, at this point, I want you to know these three keywords in difference. One is called as training data, testing data. And now, importantly, people talk about something called as validation data when you come to deep learning. So, what is this three keywords? So, I have a data, there's no class label for the data, right? So I create a class label. using some unsupervised model. So what I have created is a training data. That's all. Now a training data is available. That means there is some data, there is some columns, there is a class label. Now I give a data and predict. It's called as testing data. So training data is 70%, testing data is 30%. Right? Now, the next keyword that we are taking to the other side is something called as validation. So what is validation data is? When you come to deep learning, what deep learning will say is, there is a training data that's perfect, but you create a validation data. Validation data is also like test data. First point. Now, what you will do is you will give a validation data and you will check how much amount of accuracy you have achieved. If your accuracy is less, what you will do is you will go on increase your validation data. You keep on doing the improvement in the validation data until you get a perfect model. What does a perfect model means? You got a deep learning model which gives you higher accuracy for the given test data, right? Now, then what you say is you give a test data, the model will classify it very much accurate. So now people should have understood that a validation data is also like test data, but a validation data is given to a deep learning model to find a set of parameters where you can get a higher accuracy. Once you get a higher accuracy, you can give a test data and you can validate your deep learning model. So deep learning will have training data, testing data, and it will also have validation data, right? Now let's come to this part. How can you reduce overfitting? One answer would be like you can go for cross validation. What is cross validation is you can actually take your training data, right? And instead of saying 70% training, 30% testing, right? What you can do is you can further reduce it. You can say I'm taking 30% of training data from the original training and 15% from the testing data that you have, and I'm trying to see how much amount of accuracy I'm getting. This is something like you're creating multi-training testing splits, right? Since it's deep learning, you will anyway try to tune the hyperparameters, right? And see how much your data is improving. This is called as cross-validation. The second one is people will say increase your amount of data, naturally overfitting will get reduced. The third one is something called as data augmentation. What is data augmentation is you can have a data that you have, which is a sample data, but you can try to have the data at different time intervals, right? For example, if you say I've got a temperature for the day, rather than looking at the temperature from morning 9 o'clock to 4 o'clock in the evening, if you can look at the temperature at every changing times, it can be for 24 hours, let's take a case. You would say that I have got a improved data, which is called as data augmentation, right? Data augmentation in terms of images is taken very differently. For example, if you take your face image and you do a 360-degree rotation of the image, you have 360 images. Fine. And on that each of the images, if you are doing some transformation, like you are trying to increase the scale of the image, right? There, what you are achieving is something called as data augmentation. Next way that you can reduce overfitting would be like you can try to reduce the complexity on the given data, right? And you can try to reduce the challenges in the given data also. You can make the data as very simple. Their overfitting also will get reduced. Last approaches people say is like it is left to the machine learning models. You can take multiple classifiers, you can do ensembling, or you can go for boosting based classifiers like AdaBoost classifier, right? Or you can go for bagging based approaches also to reduce overfitting here, right? This is all you can actually do around your data. Now, if you say I have some data with myself, I'm interested in processing the data. Let's see how it will do from a neural network perspective. Then we'll come to some data, then we'll go to the architectures, right? Now, what you see from here on the screen, you can see that there is some cells which are filled with yellow color, which represents the current active cell, right? Okay, and wherever you say that there are some cells which are marked with orange, right? It will represent the input that will be allowing you to populate the cell, right? Let's come to the information part. If it's a neural network, what we say from a neural network, there is some input, right? There are some weights which are marked with blue. There is a bias marked with brown, and there's an output that we are able to get at every epoch, right? Now, what we are talking about here is where we talk about output with only one single hidden layer, right? So at the output layer, what we want to say is we'll have one neuron, and we are talking about a classification problem, which is a binary class. That means either the output will be either 0 or it will be as 1, right? Okay. Now, let's look at the understanding. We take an input and we take an output. So X is called as the input matrix, as you can see here, and Y is called as the output matrix that we have. So given set of inputs like this, we want to know what is the equivalent output, right? Now let's come to what the neural network will do. We have to first initialize the weights and the bias, right? This is what I told to the participant also. The weights can be initialized based on some common rule that you want to provide, right? So normal operation would be like you can give an initial value for the weights, and at every iteration the weights can change. Okay, right? At every iteration you can actually say that the weights are changing. Now here WH is called as a weight matrix, and BH that we have provided here is called as a bias matrix, which is given to the hidden layer, right? And W out is called as your weight matrix in the output layer, and B out is called as your bias matrix, which is given at the output layer, right? So output layer, in the sense, if you can see in the diagram, this is your output layer. Fine, okay. And your expected output matrix is Y, which is already marked here, right? Now, next step, what we want to do here is we want to go for the further computation process, right? Now, when you're going for the further computation process, our understanding would be is like we want to compute the values that we want to take it for the output matrix. So what we do here, we'll do a dot product of the input. Input is this one, right? That's a X, right? And we will try to do the dot product of the input along with the weights being provided. Weights are already provided in the weight matrix, right? And then we will add it to the bias, because we already have seen the formula summation of X, right, into W, right, plus B. That's your bias, right? Okay. This, what we are talking about, is basically a linear transformation operation, right? Once we multiply this, whatever equivalent value that we get, we will provide it to the next one, that is a hidden layer input, right? Because multiplication of data along with the inputs will be given to the hidden layer. So whatever we get in the dot product part, no, that is X into W plus B, we will give it to the hidden layer input, right? Now the hidden layer input is being populated here, right? Now the next operation that we need to do here is we need to apply your activation function. So there are different activation functions. Here what we are saying is we are trying to talk about a sigmoid, right? Okay. So when you talk about sigmoid, what it will do, it is 1 by 1 plus exp of minus x, right? Okay. So generally, if you are trying to go for the programming part, you would say that sigmoid of hidden layer input. So what is your hidden layer input? Hidden layer input is being provided already from the previous iteration. This is your hidden layer input, that is X into W plus B, right? Now, what we want to do here is we want to take your hidden layer input and apply your sigmoid function, right? So once you applied your sigmoid function using the formula 1 by 1 plus exp of minus x, so each value here is an x. So what you will be getting is your hidden layer activation, right? That is being populated here. Okay, it is 1 by 1 plus exp of x value. Next, what we want to do, we want to perform a linear transformation on the hidden layer activation, right? So the way is like, as we told you, we will take X, right? And we'll multiply by the weights, we'll add the bias, right? Then we'll apply the activation function. Here again, we are applying activation function, that is your sigmoid activation function, right? And then what we'll do is we'll use it to predict what can be the equivalent output, this part. Okay, expected output is Y, right? But what is the output that we get here needs to be populated, right? So once we apply this, we are trying to get an equivalent output, as we can see here, 0.79, 0.80, 0.79. This is for 1 epoch. Okay, that means it is run for one iteration. If you say it is going to run for the next iteration, it is called as your backward propagation. So whatever we have discussed now is for forward propagation. Okay, now if you can see here, we got an equivalent output, right? We got an equivalent output after doing x into w plus b, then apply a sigmoid function, we got an output, right? Now the expected output is this, that is y. So we want to know what is the amount of error, right? So this is called as a gradient of the error. So what is gradient of the error is the actual value that you want, right? Actual value is 110, but what you have predicted is only 0.79, 0.80, 0.79. You find the difference of it. Okay, so once you find the difference of it, it can be written here as you 1 minus 0.79 is 0.21, 1 minus 0.80 is 0.20, 0 minus 0.79 is minus 0.79. So the error value is now populated here. Now at this point, this error, when you come to the case of deep learning, we call as error in terms of training and testing. Okay, right? Or people talk about something called as model error during validation, model error during testing. Now the next is supposed to compute the slope by gradient of the hidden and output layer neurons. To find the slope, general rule is we have to find the derivative of the nonlinear activations, that is x, right, at each layer of the input, right? So the gradient that will be returned would be is like x into 1 minus x. Okay, so this has to be done with respect to the hidden layer inputs, right? Okay, so here the rule would be is like we will take with respect to the hidden layer by saying derivative of sigmoid with respect to the hidden layer activation. So we will be able to calculate the slope with respect to the hidden layer, right? And the same thing, we'll be able to see what is the slope with respect to the output also. Now the slopes are being presented here. Now the next step would be is like we want to compute the change factor. Change factor is the delta, right, with respect to the output layer. So this would be given as E into slope of the output layer, right? So what is E? E is already available here, 0.21, 0.20, 0.79, right? So first step, what we will do is we will find what is the slope error with respect to the hidden layer here, right? If you see the slope with respect to the hidden layer error, it is presented here. So we try to compute by multiplying this error, right? Okay, that is at the hidden layer, and we will try to multiply it with the slope with respect to the output layer. Slope with respect to the output layer is provided here. So we will multiply both of it. We will be able to get the delta. Once we find the delta output, then what we'll do is we'll propagate this error that getting. The error to the hidden layer is this. So this we will propagate it again back to the network, and we will go to the next iteration. Next iteration means we are going through the backward propagation. This keeps repeating for set of times. At every time what happens is the bias will be getting updated. Continue to go until the error is minimal. What is this error becoming minimal is a point at which your expected value that you want to predict actually matches to the error that you got. That means if you can see here, your expected output is 110, but your is 0.79, 0.80, 0.79, right? So here, if you see here, there is a higher error with respect to the third one, because it is 0 minus 0 minus 0.79 will give you minus 0.7. You want to continue for the next epoch, and you want to keep going until both these columns becomes the same. Is it okay? So this is how neural network does. But what is the difficulty for a neural network is, a neural network cannot increase the hidden layers. And second thing is, a neural network cannot uh, update the weights. That means what I'm trying to say is, if there are, you cannot drop one weight and I'll use.
Senthil sir, your voice is not coming. Senthil sir, can you hear me?
Am I audible, please?
Yeah, now you are audible.
I'm audible. So this is the reason why people went from neural network to deep learning, because deep learning was able to say that you can model your parameters and hyperparameters in such a way that your weights can change and the error becomes very minimal. Okay. Now the next one, which I want you to have a look at for your understanding, would be like, see, given some data, we are actually interested in saying that the data is very important because it carries some information. The information is very meaningful for all the times, right? If you can all see on the browser, I'm sharing the screen, right? There's a popular website which you can actually make a look at. One is something called as xuru.org. Okay. Um, advantage of this website is this actually gets you an insight about what are the essentials that you can do when it comes to data, and how much the concepts are very important with respect to statistics, right? Now, given some data, the question from everybody would be like, what can you do with the data, right? There are many things that you can do with the data, which is at the very basic level, and the basic steps will help you to improve the classification in the later stage. Okay. If you can see the URL, I think you're able to see the screen. Participants, are you able to see my screen?
Yes, sir.
Okay. Here you will find something called as descriptive statistics. Okay. So if you come down to descriptive statistics, it will open your window, and in this it will show you a text box. Every column of data that you want to process is giving you a lot of interesting information. If you look at your marks that you have scored in your semesters, each subject will give you a performance that you have improved over the years, right? So every single column of data that you provide always has some value, and that value can be processed for your information. Now I'm giving a set of data. When I go and click calculate, I'll be able to see the different statistical details with respect to the data, right? So statistics are very important for data science. Without statistics, there is nothing that you can do with data, right? How much is the statistics important? I will always give you an example. Normal thing is like if you say how much is the rain for a month, people say it has rained for 6 days out of 30. So you would say it is 25% rain for a month. Fine. If you go to the doctor and ask the doctor, sir, does the patient have a cancer? What is the level of cancer? The doctor will say this many number of RBC cells is there, right? But out of this many number of RBC cells, this many cells are being infected, right? So it is 25% infection. The doctor might say the level is at 1. 50% infection level is 2, for example. So there it is again statistics. Okay. You go to the doctor and ask, okay, what is the stage of a tumor for the particular patient? Based on the area, the doctor is conclude saying that the tumor is high or the tumor is low, right? So the area is again a statistical feature. So for every problem you work, please check how much amount of statistics that you can work on the given data. So if you can see this URL, you can see that there's a lot of statistical measures that will come. Most of the statistical measures are known to you. For example, if you can see here, the statistical measure is trying to conclude saying that there's something called as mean, median, standard deviation, variance, and finally it will give you something about the distribution. What is the importance of distribution is the importance of distribution would be like it will actually try to say, given some data, right, your distribution will say whether it falls into a normal model or not. This as faculties, what we will actually say is once the results have come, we are interested to see the performance of the students. Based on the performance of the students, we will try to see whether there's a moderation required for the subject. So the distribution is normally expected to be normal, but there are many other distributions also which people should be trying to know. Examples are, if you can come to this left side link, if you come to the statistical tools, you come to probability distributions, right? If you come to probability distributions and click on probability distributions, you will find under this link the different type of distributions that you come across. Most commonly, people would know that there is something called as binomial, Poisson, all that. So request everybody to have a look at these distributions because this will get back to you saying what are the stats that you are not learned. You can try to quickly go from this and try to predict, right? So distributions are very important. Now, why is distributions important is when you are trying to create models, people talk about model creation under saying that whether they are stochastic, partially stochastic, or fully stochastic models. Example, if you go to hidden Markov model, it is an example of partially stochastic. But when you come to deep learning architectures, they are fully stochastic models. So without probability distributions, you will not have any concept of stochastic models at all. So my second request to you all is learn statistical measures, and second is start learning about distributions if you're not good in this, right? The third thing would be is like given some data, most of the problems can be solved with regression models. There's no doubt at all. Regression models are the best solution to most of the problems, including COVID data. So based on your type of data, whether it's a discrete data or continuous data, please go to regression models or choose some other techniques. If you come to regression models here, you will find different regression models. Usual rule is like whether you want to go for linear or logistic regression. If your data characteristic demands saying that there is a Boolean nature to the given data, right? There, please go to logistic regression. There is no Boolean aspect at all, right? For a data that you have, right? And data is purely discrete. There, what you can go for would be like linear regression. Again, under that, people will say whether it is you're going for normal or multiple categories, right? So in this, you can find different regression techniques. Now let's click on this linear regression for our understanding. So once you click on linear regression, it will ask you whether you want to go for weighted linear regression or constrained linear regression. We will just go for normal one. So let's take linear regression requires 2 columns data to be provided. So I'm giving 2 column data. So these are my data that I have. I'm just typing, but your side, if you have it in your Excel sheet, you can copy and paste the data also. Once you do it and click calculate, what you will be able to get, right, is a line equation which you already know. The general line equation is something like y equal to mx plus c, right? So you will get a line equation like this. Y equal to mx plus c is a line equation. You can see y equal to mx, right, plus c. C is nothing but 1.8. And this line equation will change based on the data. For example, I just go here and add some more data, right? I'm adding some more columns of data here, and I'm coming to my equation generation. I click calculate. What I'll be getting is I'll be getting a new line equation. You can see here line equation has changed, right? So this is what is called as hypothesis. Okay, and this is again called as kernel, right? People when you go to support vector machines, they will say that we are following a kernel based approach. So this is a hypothesis. And same thing when you go to approaches like support vector machine, people say that I'm finding kernel. So the kernel is also a hypothesis. So wherever you want to classify your data, your challenge is to find the hypothesis. So your hypothesis can be found by using linear regression or logistic regression or any other regression technique. So this resembles a line equation wherein y equal to mx plus c. It will be called as y equal to mx plus c plus error, because the points will not fall in the line. So points will fall above the line or below the line. What is the line here? It's a line equation is this y equal to mx plus. So the points below the line will call itself as positive samples, and the points above the line will fall itself as negative samples, right? Okay. So your classification will say I have classified it as positive class or negative class. Now if you come down, you can see here what is the error value for every point with respect to your equation that you have formulated under the regression model. So if you can see here, the minimal error that you can get here is 2.78, right? And the maximal error that you get is 6.64. If you put a rule saying that anything greater than 4.3 is an outlier, so what you will say from here is this is an outlier, this is an outlier, right? And this is an outlier, and this is also an outlier. So out of 8 records of data, you have 4 records which are outliers. So people will say, how are you going to manage the outliers? So one way of managing the outlier is you can actually go back to your data and use some approaches to modify the data. For example, if you look at this, this is an outlier, right? You can see here 6.64 is an outlier. With respect to y is 44. If you can formulate a way where you are trying to change it and again go and check, right? What happens here is you can see here, this doesn't become an outlier. Now it becomes an inlier. Inlier means it is possible to classify. So the new data that is coming to the model will always increase the number of outliers. So you need to have ways to minimize the number of outliers, right? And outliers again is called as anomalies. When it comes to data, your outlier is also called as an anomaly. So you want to reduce the number of anomalies in the given data, right? I think people should have got a clarity right now. So the whole idea is like formulating a hypothesis for the given data is the need of the day. It can be regression, it can be with deep learning, it can be with any technique that you can do. But whatever hypothesis that you have formulated, if it can accurately classify the data and if it can reduce the number of outliers, your model is a perfect model. Your model is accurate. Your model can be used for new sets of data that can be arriving in the given domain, right? So this is the next thing that I want you to have a look at. And third, this people should have seen from your other learnings also. If you go to the internet browser and if you write playground.tensorflow, right, you would actually get a UI. This is just for you to understand what happens originally with respect to the deep learning aspect. See, deep learning, we have been saying there is something called as parameters, there are something called as hyperparameters in the deep learning. Now, if you can look from here, this is your part. Now, just see here, data is actually very interesting, right? If you take this data, no, just take it like this. Assume your data is like this. You will all say with a school student, no, they will say that see, there's something orange, there is something called as blue. How are you going to separate? I want to find a line. Just draw a line, right? So your line equation that you can formulate can be understood as a classification problem, which is only regression, right? Okay, but your line that you formulate, right, it is no more a line, it is a hyperplane, right? Because it's not binary class, it's a multi-class. There what you have to do is you have to go for a classification. Now, given some data like this, let's take you look at this data. This is okay, this looks nice. You can classify it by drawing a line, for example. But look at this data. Can you draw a line for doing it? No. You have to go for kernels. Now look at this one. And kernel again here is not linear, it's non-linear kernel. Now look at this here. You have to draw 4 lines. 1, 2, and that will intersect at one point. So your line equation is not going to help us. Now come to this one. Very challenging. The data is totally connected. Right? There is orange, there is red. So here orange and red means it speaks about the type of data. One type of data is having a pattern with respect to orange. Other type of data is having a pattern with respect to blue. Right? The next, what I told you, the training to testing, how much you want to have as range. Are you going to have some noise? Are you going to have some batch size? Right? People go for batch wise training. The next is, are you going to take all the features? Right? Okay. And next is, are you going to have neurons? If so, how many hidden layers? You can see here. And just increasing the number of hidden layers. At each hidden layer, you can have your own number of neurons, as I told you. Here it is 5 neurons. Here it is 3. It is 4. It's up to you. You can increase your hidden layers. The more the number of hidden layers, the model generation will be very nice. That means your accuracy will get improved. Next comes with respect to your parameters. So what are going to be your hyperparameters? What is your activation function? Here in deep learning, the most common activation function is ReLU, right? What type of regularization are you interested in following? Regularization rate are all more connected to solve vanishing gradient problem, right? So what is going to be a regularization rate? Finally, say what is your classification. Now, this here in this UI, you cannot do any program. It's just for information part to learn what actually happens in deep learning. Now look at this here. At every time there's going to be a loss. So training loss is this, testing loss is this, which is approximately set. Now epochs. Epochs is the number of iterations. Now you click, right? What happens here is the loss keeps on changing, right? So the epochs also changes. At every epoch, what happens is the loss changes. At every epoch, when the loss changes, what happens is it tries to formulate a kernel and tries to classify the data, right? The point at which the loss becomes minimal, the model will stop. Let's take you say my total model size is only 250. It might stop at 250. Or you go by the other way and say my loss will be so and so value. At that point, you stop the model, you stop the model. Okay, this is just an UI for you to quickly know what happens in the case of deep learning aspect. Now, next is going back to the coding part, writing a framework code like that. The common information I leave to people is like you can go with Python, you can use Anaconda, you can use TensorFlow, or you can go for TensorFlow is one choice. Otherwise, you can go for Theano, right? Theano is there, or you can go for TensorFlow. Either you can go for Theano or you can go for TensorFlow. So Keras will be the front end, right? So Keras with TensorFlow or Keras with piano, either Windows or Linux. It's a good choice for you to do. More realistically, people say that I'm doing an IoT based application. I'm using a third party library from Python. All that is left to you. But common frameworks that can be used would be like Keras with Piano and Keras with TensorFlow. Okay. That's all. This is what I want you to know at the first part of the session. Sir, I'm stopping here for a small break.
Yes, sir. There are some queries typed in the chat box. You can check it or they can ask now.
Yeah, they can ask, sir. I think that will be
Yeah.
better. Maybe.
Yeah.
Logistic can be used both for regression and classification problem. See, please understand, uh, regression and classification problem is, it doesn't call as regression problem or classification problem. Based on the type of data, whether it's discrete or continuous, you can use regression technique or classification technique. Regression technique means logistic linear regression, like that. If you're coming to classification technique, means then you have to go for k-means, knn, support vector mission, fuzzy c-means, like that. Any other questions?
Hello, good morning, sir.
Good morning, please.
Sir, this is Gaurav Yadav from NIT Jamshedpur. Sir, I want to ask that can we assess the images for the images also using these tools, this TensorFlow,
Which tool?
Playground Tensor, or the
Just correct me if I'm wrong. Your question is like, given a image data set, can you use TensorFlow like that? That's your question?
yes. To
Yes.
assess the things, sir. What you said now in that statistical one, sir, using the Zuru, that Zuru or org, where you assess the statistical measure of the data. So
Okay, fine. For example, let's take it like this. You have an image, okay, right? And
sir,
you have converted that image into a set of features. Fine.
okay,
So
sir.
let's take your features are more now connected like this. Your features are, just give me a second. I'll just show you like this. 1 second. I'm switching it quickly. Okay. Let's take your features are now something like color. Okay, color is your first feature.
Okay, sir.
So feature, and the second is something with respect to person. This color, and second is person. Okay. So now
Okay,
if
sir.
you look at color, you would say the color features are red, green, and blue. Person is actually a status variable, whether the person is present or not. Okay. So that becomes a Boolean. That is yes or no.
Okay, sir.
Now, you have right now, you have 4 features, right? Red, green, blue. Your features are, you have red, you have green, and the third feature that you have is blue, and you have, which is nothing but yes or no. Is it okay? Now, there are totally 4 features. Now, a basic statistical measure would say you can reduce dimensionality reduction. Dimensionality reduction means creating new features from the original data. Now I have 3 features. Okay. Now what I'm doing is I'm just creating a new feature called as average color. Right? This average color, what I'm saying is, I'm saying it is red plus green plus blue divided by 2. This is okay, right? Now what
Okay,
happens?
sir.
Now what happens with my given data is, my data is having originally 5 features. Now with my problem, I have come to an understanding that I need only 2 features: average color and next is person. Right? So an average color is an example of a statistical feature. Okay. Or if you come to the other way around, let's take it as a fire data. Hello, can you hear me?
Yes, sir. You are audible, sir.
Let's take I come to a fire data. if it is a fire data, I'm not interested in average color. I'm interested in knowing what is the mean value of red that I'm getting in every frame, right? So let's take frame 1. I'm just modifying it like this. I'm just saying frame 1. Frame 1 means image 1, right? As the fire is being captured, right? So the red value is 230, right? And next the red value is 210. Is it okay? Now, what I'm interested in calculating is what is the mean value of red that I've got, right, for a given video where the video is classified already as fire or not fire. Now, I just change it like this. So this becomes class. It says it is fire. This is fire. And let's take, I say it is 200. It is not fire. Okay. So I have got pre-frames. It is already classified as fire or non-fire. Now I want to know what is the mean value of the red, right, across all the frames. Now, if I take the mean value of the red here, it will say 230 plus 210 plus 200 divided by 3, right?
Yes,
Let's
sir.
assume that value to be x. Now, if I give a test data, right, given this test data, wherein I'm trying to say what is the red value that I have, let's take my red values, let's take 190, right? And I want to ask a very basic question, whether it will fall into a fire or not. Okay, there, the mean that I have calculated as a statistical measure from the training data will allow me to say whether it can be a fire or not. Is it okay?
Yes, sir.
Yeah. So the image as such, which is manipulated as numerical values in the problem domain, can be given to a tool like that, and from there you can calculate your statistical measure quickly. Hello?
Yes, sir.
Yes. Now, if we go around in the next stage, what you might try to say is, you might try to find the distribution across the frames, right? There are frame 1, frame 2, frame 3, and so on. You can fit it to a distribution, and based on the distribution, you can try to say whether the fire is growing on the right side or on the left side. A candle fire that you take, let's take there's a blow off where the fire lightly moves on the right side or on the left side, right? How can you predict it using your probability distribution? So your probability distribution again that you get there will help you to do that.
Sir, can you please explain the role of mean value of red color here?
Okay, see what is the need for mean value of the red colors? When you look at a fire, right? For example, you are more concerned with respect to the red and yellow, right? The more the amount of red value, you can actually say whether it's a real fire or a not a fire.
Yes.
Okay, so
Yes.
if I know that I want to create my data, what I'll do is I just put a candle lamp. I just try to take video shots. I can find what is the red value using a function code. Am I right?
Yes.
So at every frame, I got the red value. Okay. Now let's
Yes.
say the candle is becoming little brighter and brighter.
Okay.
So I get red values. So it is for the original fire. Am I right?
Yes.
Yeah. Now I give you an artificial fire on the other side. There also red pixel will come.
Okay.
Right? But if I look at the red pixel, frame to frame, if I try to see the mean value, how it is changing, I can come to a probability saying that this is not a fire, this is an original fire or not.
Okay. Yes. Yes.
So that's how you can do it.
Mm-hmm.
Have I answered to you?
Yes, sir. Yes, sir.
Yeah. Any other questions?
Sir, we can use deviation also in this context, standard deviation. Can
Standard
we
deviation
use?
also, you can use it. You can use it. You can see the purpose of standard deviation is to help to understand the nature of the data. Correct?
How much it is deviating from the original data?
Oh, yeah, you can use. You can use. You can use.
Yes. Yes.
You can use. See anything around the numerical interpretation of a column data can always fit it to a domain problem. Only thing is you need to develop some ground rules for the domain. Like I'm saying, no, take 5 data you generated, fit it to your test data, and you can conclude. Is it okay? Any other questions?
Sir, one question.
Hmm.
So as we discussed that in deep neural network or deep learning, it is basically used to, or we can increase the number of hidden layers.
Yeah.
And weight updation can be done in the hidden layer in comparison to ANN.
Yes. Yes.
Is it the only algorithm, that backpropagation algorithm, which is used in deep neural network, or any other algorithm?
See, actually, please try to understand. Forward propagation, backward propagation is one single step operation. Okay. When you start from the left to right, that means given some input, it goes to the output. What
Yes.
happens in forward propagation? Now, once after calculating the output, it checks with the expected output. It
Expected.
finds the error. It goes
Find the
back.
error,
It's
yes.
backward propagation.
Yes.
Right?
Yes.
Now, when you talk about hidden layer, when you come to deep learning, hidden layers will have different names. We will say convolution layer, we will say pooling layer, we will call them as block layers, like that. Each
Okay.
of them will have a special purpose.
Okay.
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 For example, a convolution will do a downscaling on the given data. It is a hidden layer. You can use many number of convolution. You can say number of convolution layers is 3. That means the hidden layer type is convolution layer, but the number of hidden layers belonging to convolution layer is 3.
3.
Like that.
Okay. Okay. Yeah,
Is
got
this
the
okay?
point. Got the point, sir.
Yeah.
Sir, what's the role of bias matrix? Sir? What's the role of bias matrix?
Yeah. See, actually, bias will influence the error that you are trying to get.
Oh, okay, sir. Okay, okay.
Without bias, there is no neural network model.
Okay, sir. Okay.
Because see, ultimately, when you are trying to do all this hypothesis generation, you are not trying to fit to a straight line. It is not possible at all.
Yes, sir.
Correct? So you will need a bias.
Yeah. Okay, sir. Okay.
Yeah.
Sir, can you please tell about that learning rate parameter?
Can you tell about what?
Learning rate parameter is there, sir. You have said some learning rate 0.1.
Yeah. See, learning rate as such will try to fit the data to a function which is f of x, right? Okay, and the learning rate will try to influence the error characteristic also. Okay, maybe I'll show you one more example in my next session where you can try to get a clarity on why learning rate is important. Okay.
Okay, sir. Okay, sir.
Yeah. Any other questions?
Yeah, I think there are no more questions. We can take a break and be back sharply by how much time, Senthil, you need to come back?
So 15 minutes. 15 minutes is
Yeah.
what we plan.
Yeah,
Maybe.
let us come back by 12 o'clock sharply.
Sure. We can take it like that.
Yeah. Thank you all.
Thank you all.
Thank you, sir.
Thank you all.